Okay, so now we're recording. Okay, so again, we're looking at the notes for 3.8, elastic and inelastic collisions. So whether we're dealing with subatomic particles, like really tiny stuff, or macroscopic, like just, like two cars colliding, usually kinetic energy will be conserved if you're doing subatomic, because you're not going to really be dealing with like friction or errors and stuff like that. If you're doing something that's like bigger, then of course you're going to start losing stuff to heat. So kinetic energy is usually not conserved. So converting to heat or to distortion or damage, kind of like that discussion question, like if you were driving a car, you got into a car accident, obviously you're going to see some damage to the car that you're driving if you rammed into someone, kind of like the example I gave that I had 17 years ago. So if it's a elastic collision, then your kinetic energy is conserved. But if it's inelastic, then it's not conserved, meaning that usually the objects will stick together or you'll lose stuff to heat or stuff like that. So that's what's happening in these blanks here. Subatomic, so very tiny stuff, then typically kinetic energy will be conserved. Macroscopic, then they'll not be conserved, like a car or stuff like that, because then the cars will stick, or you'll see some like smoke or heat being generated. So typically for the macroscopic collisions, you'll see some conversion of kinetic energy to heat, some distortion or damage to the car or whatever object. And again, elastic collisions are when kinetic energy are conserved, like the subatomic particles. Inelastic, like macroscopic objects, kinetic energy is not conserved. And when it's completely inelastic, the objects do stick together. So now let's actually take a look at this example here, and then we'll actually work this from scratch. So you're playing marbles, your 0.1 kilogram shooter traveling 1 meter per second, so it's basically a marble you're throwing, or you're flicking or whatever. Traveling at 1 meter per second, hits a stationary 0.05 kilogram cat's eye marble. Okay, fine. And you assume that's it's at rest because it's stationary. If it is an elastic collision, what are the velocities after the collision? Okay. So let's actually work this out. So what you're going to do is you're going to actually set up two different conservation equations, momentum and kinetic energy. So let's do this from scratch, because good day, you guys see this all done real time. So you're going to set up two different formulas here. To do them this way. We'll just do them this way. Okay, we'll start with conservation of momentum. We'll call the shooter mass 1, and we'll call the cat's eye marble mass 2. So mass 1, V1 initial, plus mass 2, V2 initial, will equal mass 1, V1 final, plus mass 2, V2 final. So your mass 1, of course, is 0.1. The V1 initial, is 1. The mass 2 is 0.05, but it's at rest, so you put 0 there. Yeah, mass 1 is 0.1. We do not know the final velocity of the shooter, so we'll just call it V1F. And again, 0.05 V2F, because we don't know the cat's eye marble's velocity either. So that becomes 0.1 on the left side. So 0.1 equals 0.1. And just to make things, now we'll just call it V1F. I know it's kind of a pain to write. If you just want to write V1, that's fine. But just for the sake of consistency, I'll just call it V1F and V2F. So the problem is that you have two unknowns. So you need the second equation. That's why we're doing conservation of energy next. Okay, looking at a huge sigh here. So then you're gonna have 1/2 m1 v1I squared plus 1/2 m2 v2I squared. I'm gonna erase this line because I'm totally gonna need more space. Equals 1/2 m1 v1f squared plus 1/2 m2 v2f squared. Again, we know the velocity of the first marble is 1. So it's 1/2 0.1 as 1 squared. And that's just going to be 0 because you don't have any velocity for the cat's eye. The initial velocity of the cat's eye marble is 0. Plus, I can probably factor out, oh, yeah, we'll factor out 1/2. And m1, which is 0.1 v1f squared plus 0.05 v2f squared. The 1/2s will actually cancel. Remember, that kind of goes away, so the 1/2s cancel. So the left side, you're going to just have just 0.1. And over here, you're going to have so now, let's make sure I'm doing all this correctly here so far. Yeah. So you have to do some sort of a substitution. It gets really, really messy. Debating if I'm going to ask this on a test tomorrow. Probably not. Maybe we'll do something more conceptual. Well, let me show you what they actually do. But hopefully you guys got everything I got so far. Any questions about the math before I move forward? Okay, no questions about the math I've done. Okay, so again, substituting things I know. Let's take a look at the nth key because I want to see how they did their substitution. I mean, we could isolate one of these variables and throw it in, but I'm just a little apprehensive because it's just really messy. So it's kind of hard to read, but you can kind of see they're doing the same thing here. Yeah, it looks like they divide both sides by 0.1 here, actually. To kind of clean this up a little bit. Maybe I'll do the same. Remember, you got to do it to all terms. So to kind of clean things up a little bit, so 1 equals v1f plus 0.5 v2f. And then they do a substitution. v1f equals 1 minus 0.5 v2f. So yeah, that's what we have here. And then they do a substitution. So they kind of replace the v1f and the, I think we can handle it. So then they replace the v1f with all that jazz over here. And you could probably do the same thing. You could probably divide each of these by 0.1. So kind of just go down here. So now it becomes 1 equals v1f squared. Remember, 0.05 over 0.1 is 0.5. 0.5 v2f squared. Then you got to do your substitution, which will look just like this. 1 equals 1 minus 0.5 v2f squared plus 0.5 v2f squared. You're going to have to FOIL that and have fun, right? So 1 equals 1 If you fill it correctly, you should get negative 0.5 V2F, negative 0.5 V2F, and plus 0.25 V2F squared, and then plus, of course, a 0.5 V2F squared. Ones cancel, get 0 on that side, and it's 0.75 V2F squared minus V2F. You can factor out V2F. So again, you have 0 on the left side. And you go on being 0.75 V2F minus 1. If you continue working it all out, I believe your V2F could either equal 0, which is not true because it's moving, or it could equal 4/3. And if that's 4/3, when you plug it in, V1F will be 1/3 if you were to work it out. Yeah, that one's a doozy. I'm not going to do that on the test. I've decided. I just think it's just a little too much for you guys. The second example, you know what? Maybe I'll do this. I'll add this extra credit. If you want to do this one, I'll put as an extra credit question. But maybe I'll make it worth like 0 points. But if you get it, just so it doesn't, or I'll see if there's an option for extra credit on a test. I'll put some extra credit question because I think this is just a little too much. I'll put some conceptual stuff for sure, like just ask about elastic and inelastic, because we have the concept at the top here. But yeah, I don't think this is right for you guys to do because there's too much other stuff going on here. Yeah, but let's look at the answer key really quickly. Yeah, looks like that's exactly what we get. So, yeah, next one's a little bit trickier. Also, like firing a gun at a block. It's kind of the same wackiness. Let's see if there's some decent ones to do, but if not, maybe we could just not worry about it. But yeah, all these are going to be pretty intense. So I think we'll not worry about that. But let's actually go back and do the rest of the problems from 3.7 and 3.4. I think we've done all the ones for 3.6 already. Yeah, we have. So I think we're okay there. So we're going to do more problem sets. And then we're going to start talking about the upcoming tests. So for 3.4, I'd like you guys to take a look at 11 through 14. But before that, let's do more work with 3.7. So I have you guys do 9 through 12. So I'll give you guys about 15 to 20 minutes to do 9 through 12. Around 12:50, we'll see if you have any questions. Then we'll have a discussion about 1, 2, 3, 4. Then we'll do a little bit of practice here, and then we'll talk about the review sets and some of the stuff I'm gonna have you guys work on tonight. So yeah, so let's do this. Yeah, I just think these problems are just gonna be too intense for 3.8. But there's a video. I'll make an extra credit. I'll do that. So if you want to do the extra practice, you could. But conceptually, I'll probably just ask them these things here as multiple choice questions, and we'll see some of the review sets as well later this afternoon before we sign off. Okay. So for what I want you guys to do in your breakout rooms will be 9, 10, 11, 12, and 3.7. So let me actually close off 3.8 so it's not distracting. I'll close off 3.4 as well. But yeah, so you guys will be working on 9, 10, 11, 12, and 3.7. 7. And then we will come back at around 12:50 to go over them. So let me stop the recording.